Hello, mathematicians. Today we're going to be learning about linear inequalities in slope-intercept form. So, linear inequalities are like linear equations. However, instead of having y equals mx plus b, we're going to have y is greater than, y is less than, y is greater than or equal to, or y is less than or equal to. So here you'll notice that if we have y is greater than or y is less than, we're going to use a dashed line instead of a solid line. And if we have greater than or equal to or less than or equal to, we're going to use a solid line. So the dashed line and the solid line helps us tell the difference between greater than or equal to, or less than or equal to. So here we have y is greater than 2x minus 5. So because we have y is greater than, we're going to use a dashed line. So we're going to plot this as we normally would first, and then we're going to use a dashed line through our points. So because this is y is greater than 2x minus 5, here we have our slope, which is 2 over 1. And here we have our y-intercept, which is negative 5. So we're going to start at our y-intercept, negative 5. And because our slope is positive, from negative 5, we're going to go up 2 to the right 1. We're going to go up 2 to the right 1. And that's because both our 2 and our 1 are positive. Okay, so here I have a few points, and I'm going to draw a line through these. And remember that our line has to be a dashed line whenever we have greater than or less than. So here we have our dashed line. And because we have y is greater than 2x minus 5, we're going to have to shade either above or below the line. So because it's greater than, we're going to shade above the line. But an easy way for us to tell if we're shading in the right section is we could pick a coordinate. So if I pick a coordinate here to the left of my line, and it's true for this statement, then that's how I know I'm shading the correct area. But if it's false, then that means I need to shade the opposite area. So the easiest coordinate that you can pick if your line does not cross through it is 0, 0. So using 0, 0, I'm going to substitute the y and the x value in our inequality and see if it's true. So instead of y, I'm going to put a 0 here. 0 is greater than 2 times 0 minus 5. So 0 is greater than 2 times 0 is 0, minus 5 is equal to negative 5. So 0 is greater than negative 5. And this is true. So if it is true, that means that this is the side I'm going to shade. So if this coordinate here is true, then that means that any other coordinate I pick to the right of this line will be untrue. So let's just pick a coordinate just so I could show you as an example. So if we pick the coordinate 5, 1, this point should be untrue. So this one is true. So this one should not be true. So I'm going to erase this. And we know that 0, 0 is true, so let's try 5, 1. So the y value here is 1, so 1 is greater than 2 times 5 minus 5. So 1 is greater than 2 times 5 is 10 minus 5. So 1 is greater than 10 minus 5, which is 5. 1 is not greater than 5, so this is not true, making this point not true. So because this point is true to the left of the line, that means any other point that I pick in this section will be true, and any other point to the right of this line would not be true. And so that's why we're going to shade in everything to the left of the line. So everything to this left, everything to the left of this line is true. So it gets shaded. So this is how we represent y is greater than 2x minus 5. We drew our line, and it's dashed because it's greater than, and so we shade everything that is greater than this line. So any point in this section is a true statement, so it would be a solution to this inequality. So here we have another example. Y is less than or equal to 2/3 x plus 1. So the first thing we do is we're going to graph this as we normally would. So 2/3 in this case is our slope, and 1 is our y-intercept. So our slope is 2/3 and our y-intercept is 1. So we're going to start at 1. And because our slope is 2/3, we're going to go up 2 to the right 3, since they're both positive, up 2 to the right 3, up 2 to the right 3, and then we're going to draw a line through these points. Now, because I have y is less than or equal to, this line is going to be a solid line. So we're going to draw a solid line through these points. And now we're going to see which section we could shade. So 0, 0 is available because this line does not go through it. So we could see if this point is true. So 0 is less than or equal to 2/3 times 0 plus 1. So 0 is less than or equal to 2/3 times 0 is 0 plus 1. 0 is less than or equal to 1, and this is true. So this point is a true statement. And we could test out another point on the opposite side of the line to see if it's not true. So I'm going to pick the point. So you can pick any point you really want to. I'm going to pick the point, let's say 2, 4. So our y value is 4, so 4 is less than or equal to 2/3 times 2 plus 1. So 4 is less than or equal to 2/3 times 2 is 4/3 plus 1. So 4/3 is the same thing as 1 1/3 plus 1. So 4 is less than or equal to 2 1/3. So this is not true because 4 is not less than 2 1/3, and it's definitely not equal to it. So this point is not true. So because the true statement is underneath the line, that is where we're going to shade. So we're going to shade everything underneath this line. So everything underneath this line is a solution. And that's it for this example. So here we have another example. Y is less than negative 3x plus 6. So we're going to graph this as we normally would. So keep in mind that because we have y is less than, we're going to have a dashed line. So negative 3 is our slope. So negative 3 over 1. And 6 is our y-intercept. So for this inequality, we're going to start off at 6 as our y-intercept. And because our slope is negative, we're going to go down 3, and then we're going to go to the right one. And the reason why we go to the right one is because the 1 is positive. So we're going to go down 3 to the right 1, and so on. And since I have a few points here, I could just draw my line through this. And because it's y is less than, just be mindful that it's a dashed line. And so again, you could pick any point, but the easiest point to pick is 0, 0 if the line is not on it. If the line is on it, you could not use it. So if we use 0, 0, we know that 0 is less than negative 3 times 0 plus 6. So 0 is less than negative 3 times 0 is 0 plus 6. So 0 is less than 6. And that is a true statement. So now let's just double check that a coordinate on the other side is not true. So we could pick any point that we want to pick. So if we wanted to, we could pick 4, 2. So the y value is 2 is less than negative 3 times 4 plus 6. So 2 is less than negative 3 times 4 is negative 12 plus 6. So 2 is less than negative 12 plus 6 is negative 6. So 2 is not less than negative 6, so this is not true. So because that's not true, we know that we have to shade this section down here. So we're going to highlight underneath this line over here to the left of it. And then we're going to highlight everything on this side. Because these are all true. And that's it for this example. So here we have our last example, and we're going to start off the same exact way. We're going to treat this as we normally would a linear equation. Just be mindful that because y is greater than or equal to, it is going to be a solid line. So y is greater than or equal to negative 1 over 4, which is our slope. And then plus 7, which is our y-intercept. So we're going to start off at 7, and because our slope is negative 1 over 4, we're going to go down 1 to the right 4. We're going to go down 1 to the right 4. And then so on. So here I have some points already. So I'm going to draw a solid line because it's y is greater than or equal to. So here we're going to test out some coordinates to see which side we should shade. So again, 0, 0 is the easiest point that we could use. So 0 is less than or equal to negative 1/4 times 0 plus 7. So 0 is greater than or equal to 0 plus 7 because negative 1/4 times 0 is 0. So 0 is greater than or equal to 7. So that is not true, meaning that we should shade above the line. But let's use a coordinate just to double check from the other side of the line. So we could pick the coordinate, let's say 8, 7. So in this case, the y value is 7. So 7 is greater than or equal to negative 1/4 times 8 plus 7. So 7 is greater than or equal to negative 1/4 times 8 is negative 8 over 4, which is negative 2, plus 7. So 7 is greater than or equal to negative 2 plus 7 is 5. So 7 is greater than or equal to 5, and this is true. So we could shade above this line. And that's it.